How's it going, ladies and gentlemen? Mr. Donahue here. We're going to take a look at molarity and dilution. So first we're going to address, well, what is molarity? And we're going to talk about why is it a useful measurement? Why do we bother measuring things in molarity? How do you make dilutions? So we're going to explain the equation, and we're going to do some sample problems so you guys get a feel for it. So first question is, what is molarity? Well, the simple definition is molarity, which is usually a capital M, equals the moles of the solute, the stuff that's being dissolved, divided by liters of solution. So that's the simple definition. It's moles divided by liters of solution. So when is it used? All the time only. That's it. Just like all the time in chemistry. Whenever you have a solution and reactions, you're going to be using molarity. It's going to come up a lot. So calculating molarity. Given moles and volume, the question is, what is the molarity of a solution containing 2 moles of KNO3 in 4 liters of solution? So first, let's call upon our knowledge of what that formula is again. Molarity equals moles over liters. So let's see, they told us moles and they told us liters. So it's just a simply plug and chug. 2.0 moles over 4.0 liters. Beep bop, boop. And you get 0.50 molar. So that is the unit, big capital M for molar. So that would be the molarity of this solution. Similar problem. What is the molarity of a solution if it contains 2 moles of NaCl and 250 milliliters of solution? Interesting. So again, it's molarity equals moles per liter. Right? And they gave us milliliters. So we got to convert milliliters to liters, which is 0.250 liters. You got to be careful. You got to make sure your volume is in liters. So now it's a plug and chug. 2.0 over 0.250 moles over liter. And we get beep pop boop 8.0 molar. A little different here. What do we do if we're given grams? If we're given grams, well, what are we going to do? We know molarity is moles per liter, but they didn't tell us moles. They told us grams in this problem. It says, what is the molarity of a solution if it contains 20 grams of NaOH in 2 liters of solution? What do I do? What do I do? Panic? No, chill out. Okay, and look up the formula for converting between moles and grams. That's it. Moles equals grams divided by GFM. So we got 20 grams over, we got to look up what the GFM of NaOH is. Na is 23.0, oxygen is 16.0, and hydrogen is 1.0. So we add them all up and we get 40.0 grams per mole. And that is the GFM. So now we got the moles. Right, we get 20 divided by 40 and we get 0.50 moles. Now it's a plug and chug. Now we can use this equation up here. So now we got molarity equals 0.50 moles divided by 2.0 liters, and we get 0.25 molar. So for this one, it was 1, convert grams to moles, and then 2, find the molarity. That was it. Not a big deal. All right, well, what if you want to solve for moles? And this problem says how many moles of NaOH are needed to make 4 liters of a 0.50 molar solution of NaOH. All right, well, this is going to call upon some basic algebra skills, real basic. So we got moles over liters. And what we want to find is moles. So how do we get moles by itself? Times each side by liters. And you get moles equals liters times molarity. So we got liters, 4.0 liters, times the molarity, 0.50 molar. And you get 2 moles. That's it. Not that bad, huh? One more different kind of problem, solving for liters of solution. So we want liters. Again, what would your final volume of a solution need to be in order to make 2 molar solution using 0.5 moles of solute? So again, we start with our equation, and this time we want to get liters by itself. So we got to first get it on the top, so times each side by liters. And now we got to get liters by itself, so divide each side by molar. And you get liters equals moles over the molarity. That's plug and chug. 0.50 divided by 2.00, and you get 0.25 liters. That's it. That's just a little algebra. Don't let that scare you. So now we can move on and talk about dilutions. What are dilutions? Well, essentially, dilutions, you probably know already. It's when you make something less concentrated. So over here, we're starting with a certain amount of red dots representing our solute dissolved in a certain amount of solvent. So we got solution over here of a certain volume. And now over here, well, we kept the same amount of stuff, same amount of solute. If you count left and right side, they're the same amount of solute, but we changed its volume. So now it's less concentrated. So dilutions we're making, less concentrated. So here's a visual representation of that. Here we have a very concentrated solution over here with a colored dye and some water, and you can see it's really dark. And then we added and we diluted it, and we made it less concentrated, diluted it some more, made it less concentrated, so on and so forth. And you can see visually how much stuff is in there. Here, the really diluted one has less stuff, which is why it's more pinkish instead of a dark red. So the calculations, the formula for this is M1V1 equals M2V2, where M is the molarity, and the 1 is saying initially, so that's what you started with, and the V is the volume. So 1 is saying initially, 2 means you change it, the new set of conditions. Right? And I want you to take a look. I'm going to a little math sense here. So let's think about this. Molarity, the units are moles per liter, and the volume is going to be in liters, right? Same thing with the other side. Well, what happens when we have moles per liter times liter? Liters cancels out, and we're left with moles. And the same thing on the other side. Liters cancel out, and we're left with moles. So it's basically saying the moles that you start with have to be equal to the moles you end up with, which is true for a dilution, because all we're doing is adding water or whatever the solvent is to make it less concentrated. So this is the go-to equation right here. Sample problem. You start with 1 liter of 6 molar HCl and dilute it to 6 liters, and it wants to know what is the concentration of this new solution. So we go to our equation, M1V1 equals M2V2. This, it says you start with, so we know that is a volume initially, and this is our molarity initially, because that's what we started with, and it's saying we make a new volume, so that's V2, and it wants the concentration of the new thing, so it's asking for M2. Now I'm a big fan of getting the one thing that we're trying to solve for by itself and rearranging everything, because one letter is a lot easier to deal with than a really big number with a bunch of digits in it. So I'm trying to get M2 by itself. So I divide both sides by V2. And what am I left with? I'm left with that equation that I want. M2 equals M1V1 over V2. So now it's just a plug and chug. M1 was 6 molar. V1 was 1 liter all over V2, which was 6 liters. The liters cancels out, and we're left with 1 molar. So if we started with 1 liter of 6 molar HCl and we diluted it till it was 6 liters, we'd have a 1 molar concentration. I think I got one more for us. How much 0.1 molar NaCl solution can you make from 100 milliliters of 2 molar NaCl? So this from is telling us that this is what we started with. That was my initial volume, and that was my initial molarity. And this over here is a molarity, so that must be the new molarity. So again, my formula is M1V1 equals M2V2. And here they're asking how much, so they want V2. So that's what I'm trying to solve for. So again, get V2 by itself, divide both sides by M2. And what happens? Well, M2 on this side cancels out, and I'm left with V2 equals M1V1 over M2. So now it's just a plug and chug, piece of cake. M1 over here, 2 molar, times V1, 100 milliliters, divided by M2, 0.1 molar. Molars cancels out. My units will be left with liters, or I'm sorry, milliliters. So I just beep, bop, boop, and I get 2,000 milliliters as my final answer. I got 200 divided by 0.1. I get 2,000 milliliters. All right, one more. How many milliliters of 0.6 molar HCl are needed to make 100 milliliters of 0.1 molar? So I'm trying to make it. So let's see. We got M are needed to make. So this stuff is going to be my new volume and my new molarity. So this must be my initial, and they're asking for V1. So we got M1 V1 equals M2 V2. I got to get V1 by itself, divide each side by M1. And what am I left with? V1 equals M2 V2 over M1. So now it's just plug and chug. So much easier than dealing with all those digits and numbers and stuff. I just plug them in once and I'm done. So M2, 0.1 molar times by 100 milliliters all over my initial molarity of 6. Right? And I didn't do this math out yet, so what do we get? I get 10 divided by 6. I don't have a calculator. Dupe. And I get 1.667, right? So 1.67 or 1.67. It's a repeating thing, right? And the units for that, well, the molar cancels out, and I'm left with milliliters. That's kind of impressive. You only need 1.6 milliliters to make 100 milliliters of 0.1 molar HCl if you're starting with 6 molar. All right, well, I hope you found that helpful. I'll save this stuff for next time.